Alright, yes, prep. Let's get started on another video for pre-calculus. The unit that we've been in is function operations and transformations. And so what I've done is I've put together a problem that involves a variety of skills we've been studying. So let's look specifically at this problem. Shown below are the functions f of x and g of x. Using the following information, answer the questions that follow. The function f of x is a parabola with its vertex at the point 4, 3 and the two roots 1 and 7. The function g of x is determined to be g of x is the cubed root of x, and the graphs of f of x and g of x intersect at this 1.667, 1.185 and 5.892, 1.806. Because this problem was designed to be a non-calculator question, I decided to give you those two intersection points. We may or may not use those in the course of this problem, but you never know. So what I want to do right now is just kind of get myself acclimated with this question. So we have f of x, which is a parabola. Now on the graph, they're both black, and so I'm going to trace out the parabola in the blue. Now in the middle of a test, you probably won't be able to do this, but I think this is good practice. The parabola is going to be the blue. This is the graph of f of x. The cubic is, not the cubic, I'm sorry, the cubed root is what I'm going to trace out in the red, and this is the function g of x. G is the cubed root of x. Additionally, we were told their intersection points. The intersection points are right here. I'm going to label this point A, and this point is B, where A is approximately the point 1.667, 1.185, and that seems to match in terms of the location on the graph. And B is approximately the point 5.892, 1.806. And your pre-calculus teacher may not have told you this yet in the course, but in the AP Calculus exam, especially on the calculator active section, it is perfectly acceptable to indicate roots and maximum points and intersection points as just A and B on the graph, as long as you then indicate exactly what A is and exactly what B is. So with that, let's get going on this problem. And I'm going to do a little bit of back and forth here. Part A, determine the equation for the function f of x. Well, let's remember that f of x was the parabola, so that's the blue one. And I know right away that for any parabola, I can write it in vertex form, which is this f of x equals a times x minus h squared plus k, where the vertex is located at h and k. Now, specifically in this problem, we were told that the vertex is located at the point 4, 3. I wouldn't want to make that assumption, but I was told that in the beginning. So what that tells me is that h is equal to 4 and k is equal to 3. So my parabola now has the form f of x equals a x minus 4 squared plus 3. Great. I still need to figure out the value for a. Now, A indicates the direction of opening of the parabola because the parabola is concave down. I know that A is going to be less than 0, so no matter what happens, we already know that. But that's about all that I know right now. In order to figure out A, I'm going to have to use another point on the graph of the parabola. We were told specifically that the parabola has roots at 1, 0 and 7, 0. So I can use either of those points over here to figure out the equation. I'm going to use the point 1, 0. So I get 0 equals a, don't know what that is, times 1 minus 4 squared plus 3. Well, let's clean that up a little bit. 1 minus 4 is negative 3. Negative 3 squared is 9. So we have 0 equals a times 9 plus 3. If I subtract 3 from both sides, if I then divide by 9, I'm going to get that a is negative 1/3. So f of x is negative 1/3 x minus 4 squared plus 3. Done. That's part A. Now that we have that, let's see where else we're going to go. Part B, we're asked to determine the exact value, no approximating here, of f of g of 8. Well, to find g of 8, I have to evaluate the function g, which we were told is the cube root of x. So we're going to take the cube root of 8. Once we get an answer, we're going to evaluate f at that point. Well, the cube root of 8 is 2. To find f of 2, we're going to have negative 1/3. 2 minus 4 squared plus 3. 2 minus 4 is negative 2. Negative 2 squared is 4. Negative 1/3 times 4 gives me negative 4/3 plus 3. I can get a common denominator. Negative 4/3 plus 3 over 1 is the same as negative 4/3 plus 9/3. And so we get 5/3 as the exact value for f of g of 8. All right, let's keep going. Part C, find the exact value for g inverse of negative 3. Now, when I work with the pre-calculus students, and even with the calculus students, and even when I'm doing a problem like this myself, this inverse notation, g inverse of negative 3, that is the same thing as asking the question, what value of x makes the function g equal to negative 3? These two notations mean exactly the same thing. I prefer working with the second version. G of x is the cube root of x. So in order to figure out where is the cube root of x equal to negative 3, I'm going to cube both sides. Cube root of x cubed just gives me x. Negative 3 cubed, negative 3 times negative 3 times negative 3 is negative 27. So g inverse of negative 3 is negative 27. And that's part C. What I like about this problem, when I built this problem, I wanted to build in just a nice combination of skills that we've been studying in this unit that we could solve pretty quickly. All right, D. Let the new function j be created by vertically stretching the graph by a factor of 3. Now, a vertical stretch means that we are going to multiply all of the y values by 3. So before we had f of x, now we have 3 times f of x. And then translating the graph down 4 spaces. If I'm going to translate the graph down 4 spaces, what I'm going to have to do is subtract 4 from the function 3 times f of x minus 4. That means that j of x is the new function 3 times f of x minus 4. If that's all the question was asking for, then I'd be done. But I need to find the inverse. So let's see. So to find j inverse of x, well, first of all, let's go back here. I went a little too fast. We know that j is 3 times, not f of x, g of x. Sorry about that. 3 times g of x. Well, g is the cube root of x. So the function j that we're interested in is 3 times the cube root of x minus 4. Well, the way that we find an inverse is we first rewrite the problem as y equals. So we have y equals 3 times the cube root of x minus 4. We switch the x and the y. So x is 3 times the cube root of y minus 4. And then we solve for y. 3 times the cube root of y minus 4. If I want to solve for y, we're going to add 4 to both sides. And we're going to divide by 3. So we get x plus 4 over 3 equals the cube root of y. To get y, we're going to cube both sides. And so we get y is equal to x plus 4 over 3 cubed. Now, I hope your pre-calculus teacher has been demanding that when you are asked to find an inverse, you need to write your final answer as the inverse. So this is not y equals x plus 4 over 3 cubed. We need j inverse is equal to x plus 4 over 3 cubed. That there is the inverse for the function j that we built. All right, let's keep going. E, for what values of c will the graph of f of x plus c have no roots? Well, let's see. We're going to need to go back to our graph of f of x. And this c value is a vertical translation. Okay, and that's notation, or I'm sorry, that's a vocabulary term you should be used to at this point in the unit. If I have a function plus some value, that value will shift the graph up c spaces if c is positive. It'll shift the graph down c spaces if c is negative. And so we want f of x plus c to have no roots. Well, let's go back and look at f of x. F of x is this blue graph. It's the parabola. If I shift the graph of f of x up at all, so it now goes up here, I'm going to have two roots. No matter how high up I shift the graph, because the parabola starts at the vertex and widens as we go to the left and the right, no matter how far up you shift the graph, you're going to have two distinct roots. So the only option for us, if we really want to get no roots, is we need to shift the graph down. If we shift the graph down just one space, the vertex will be right here. Again, the graph widens as we go left and right, so we would have two roots. Well, what if I shift the graph down 3 spaces? If I shift the graph down 3 spaces, then my vertex is on the x-axis, and that gives me now just one root. But since we want no roots, what we need is we need to shift the graph down at the very least. We need to shift it down just a little bit more than 3 spaces. So since we are shifting down, what we need is for the c value to be less than -3. For example, -3.0001 is less than -3. If we shift the graph down 3.001 spaces, now the vertex is just below the x-axis. That is exactly what we needed. So c must be less than -3. And strictly less than, because if c was less than or equal to -3, then we would have a root, and we don't want that. Okay. F, G, and H get a little trickier. In part F, we are asked for what values of x will f of x minus g of x be less than 0. And before we actually answer this question directly, I want to go off on the side. And instead of thinking about functions, I want to think about numbers. If I were to tell you that a minus b, one number minus another number, is less than 0, the only conclusion, the only way that this can be true for a number minus a second number to be less than 0 would have to be if the first number is smaller than the second number. So a is less than b. That's true for numbers. That's also true for functions. We're looking for values of x that make this inequality true, that f of x is less than g of x. Well, what does that mean? We're going to go back to the graphs. And this is why I wanted to have the colors. F of x is the blue graph. G of x is the red graph. If I want to know where f, the blue, is less than g, the red, well, all I have to do is I'm looking for x values where the blue graph is below the red graph. So, for example, here at -1. The blue graph is down here, the red graph is up here, the blue is less than the red. That's also true at -3. Now we want to keep in mind that even though we don't see the graph going on forever, this is a parabola, and we know that parabolas extend out forever in both directions. The domain is -infinity to infinity. So f of x, the blue, will be less than the red for all values of x until we get to a. Once we hit a, the blue graph is on top of the red. And then after the intersection point, this is b, after b, the blue graph is below the red graph. So how are we going to write this up? Let's see. We're going to have that f of x is less than g of x